Good evening, everyone. I'm Kunal. I work as a technical program manager and have worked across automotive, semiconductor, and consumer electronics space in various Fortune 500 companies. So, on this topic, so quality lived in this operator's hand and head, right? It didn't scale like mechanism. Like if we go to the history of the manufacturing, so mechanization, so we got scale, but scale cost exposed variation as the real challenge. Inflection point, like we learn to make loss visible and eliminate systematically with OEE, standardized work, zero loss thinking, and then gradually automation industry 4.0, we started capturing data at the source in real time. And then currently, with AI integrated, we now compress the time it takes to see a problem and augment human judgment, right? So automation and traceability aren't a new religion. They are the next turn of wheel manufacturing engineers have done before. Uh, today's conversation is really about the transitioning from like manual to automated to AI integrated now, and more importantly, how we can make the transition without breaking our operation. Let's start with where we actually are. So every factory floor we walk into today sits somewhere in this line, moving from manual inspection towards automated inspection, toward connected IoT, industrial IoT, towards AI assisted decisions. So none of that is news to most of us, right? But what's new is the decision systems uh, underneath it. So over the next 10 minutes, we'll cover five things: how automation and traceability actually moves the needle on efficiency and quality, what real-time monitoring and analytics do for decision making, how we build true end-to-end traceability across materials, process, and finished good, what actually makes this hard to implement, especially at scale, and how it ends up strengthening compliance and customer trust. The thread running through all the five is the line at the bottom in this slide. Automation used to be a tool we bolted on a process. Now it's big, I mean, becoming a backbone on the process that runs it, and even a competitive advantage now in the next uh, time frame. So here's the trap a lot of organizations fall into. We typically invest heavily in automation and traceability. The dashboards multiply, the reports multiply, and somehow the decisions s- might not get necessarily faster or better. So that's left side of the slide. A big data pile, more inputs, no real funnel, everything pointed in different direction, and yeah, the right side is what we are actually paying for when this work. Raw signals get filtered down to what matters. That hits a real decision point, someone X, and clocks move faster. The three lines on the right aren't abstract benefits. Each one is specific points where automation either catches something before it gets expensive or it doesn't. Governance basically is like as a decision system, a checklist that we something that look into, and a decision system sense something that was already acted on. So this is probably the most distinction in this, and sounds too simple to matter until we sat in a review where it did. Like a status update is one, yeah, someone's update recorded one, trusted becomes nobody has a time or the appetite to double check it, right? A traceability record is different in kind, not just in source. It's a machine vision, sensor logs, and inspection records, all independently saying the same thing happened. None of them needed the others to vouch for them. The right side of this slide is why the distinction matters. A shift report confirms a problem after the fact, once someone notices and writes it up. A live anomaly flag catches it the moment even the data starts drifting proactively. That gap between the confirmed late and flagged early is the entire business case for traceability. And it's also how fast you find something is wrong in the system. So four tools, and I want to share insights on all of them in the next minute because uh, it really matters, especially in automation. So SPC is the simplest. It's just asking process behaving normally right now, or it has started to create a drift. Then Monte Carlo simulation or probabilistic planning is the one people misunderstand the most. It's not just a prediction, it's a range, and why that probability we actually hit this deadline or this spec runs across the thousands of possible scenarios instead of just one optimistic guess. And since the processes are and product development are is started to get complex, the probabilistic planning also starts to matter more than ever before. uh, FMEA triage of everything that we could go wrong, so that should be also be a key attribute of the automation. And then a design of experiments is how we stop guessing at variables one at a time, and we test all the combinations together to find out which ones actually drive the outcome. So none of these four makes the decision ultimately, like what they do is the evidence behind our decision much better and harder to argue with, right? Okay, so the real traceability starts as intake, a raw material lot tagged and linked to a supplier. Its certificate not just part of number. Every station after that, machine vision or uh, industrial IoT sensors, inspection, time spent, the unit as it passes through. By the time we get to the finished product, it's not carrying an isolated number. It's carrying the full chain back to where it originally started. Especially in this time, the digital twin layer on the top of this is what lets us replay any single unit's entire history end to end instead of just looking up where it is right now. So end-to-end traceability isn't a database lookup. It's an unbroken change, and that distinction matter enormously. The first time something goes wrong, and we need to know exactly uh, how far back the problem goes or identify the root cause of the problem. Okay, so I want to be precise about what AI is actually going to do here, because this is where we either trust it or dismiss it, and both reactions miss the point. Uh, so the dashed line is human detection through periodic reporting here. It only catches something at scheduled checkpoints, and by the time it's confirmed, it's already late. And the solid line is AI watching continuous data, and it flags the deviation almost the moment start. And that's a real difference, and it's valuable. But notice what it's compressing. It's compressing time taken to identify the problem, like time to detection, not necessarily the time to decision, right? The decision and the accountability for that decision stays with the leader, like a person, right? The actual risk isn't AI being wrong occasionally. Every system is wrong occasionally, and that thing to continue to change as the hardware and overall infrastructure keeps on improving along with AI. The risk is a team that stops questioning what AI flags because a signal nobody validates. It's just a faster way we can go wrong while we may happen make this transition. Okay, so uh, where automation and traceability gets hard, it gets hard, especially at scale, right? So none of these challenges are like exotic, and that's almost the problem. They are familiar enough that people, or like basically we underestimate them from our example. So legacy systems were never built to talk like a big sensor network. So integration ends up costing more than sensors themselves. Integration at scale, like it requires infrastructure level, yeah, and connectivity. Data silos means every function runs its own records on and nobody else, right? Infrastructure cost is easy to justify on paper and harder to defend 3 months into the budget cycle. Workforce upskilling also matters eventually, because the system is only good as the people we trusted to act on, and it shows. Cyber security exposure will continue to grow with the new industrial IoT endpoint. And probably the hardest one to say out loud, resistance to validate data replacing self-reporting status, because someone's judgment call stops being the final word. And none of that changes at global scale. It just compounds, especially if there are like teams working in different time zones. So it compounds decision latency across different time zones, inconsistent reporting across sites, accountability gaps across functions. And yeah, something which is not covered here is also the computing and cloud infrastructure will eventually, uh, yeah, there will be a trend and required along with this infrastructure. So yeah, solve the first six with discipline, and then solving the global version with XP structure, not by this same infrastructure with scale automatically, is a takeaway. And then if we take one thing out overall, so every shift we walked like today comes back to the same underlying discipline, treating automation and traceability as a decision system, not a compliant checklist. Demand a cross-validated evidence as our baseline standard of truth, not self-reporting status. Using statistical process control, Monte Carlo simulation, FMEA, DOA as lenses of visibility, not overall yeah, proof in itself. And building traceability as an unbroken chain, raw material to shift unit, not a serial number lookup. So yeah, overall, a speed with Judnem was never about making decision faster on its own sake, but it has always been about making decisions we can defend at scale. Uh, so yeah, that's the presentation, and then there are few slides currently in practice. So AI can enhance decision visibility in hardware programs. It can improve as we see all the at infrastructure and scale. It can improve the overall visibility and proactively identify the gaps beforehand. That is one example, right? And then second one, especially in supply chain, it can improve the overall traceability end to end, like either with tier one supplier, tier two supplier, uh, and yeah, probably give real time visibility as well as identify a single point of failure, which can be cost intensive and break the entire especially in manufacturing like automotive, right? Like entire supply chain infrastructure really matters, and even single point of failure may lead to line down situation and cost like in thousands or like lakhs or millions. So yeah, this can solve a real good problem. Even yeah, anomaly detection in manufacturing programs. So uh, identify if the process control uh, is like not consistent, so it can trace it beforehand, as we all know, right? The last slide is overall with integrating AI into the along with IoT and into the industrial automation. Uh, it will probably serve as an essential early warning system along with the automation part of it. But uh, yeah, like and then it like a cost of detection or identifying a problem will be significantly better, and time to react and make decisions will probably improve exponentially. But at the same time, yeah, the decision will ultimately still be a human in the loop. So, and yeah, like, and also this slide is basically a financial value uh, justified with the cost of reduction. So, and proactively addressing the risk. So that's pretty much everything I had. I'm open to take any questions if you require.